Assalamu alaikum. I am Muhammad Rahman 17ME47. The engine assigned to our group is a Wartsila 18V25 Nohab. So here is the engine model assigned to us. There are only two group members at Sham Ali 17ME27 and Muhammad Rahman 17ME47. So the outline of our presentation is first we will give a brief introduction to the engine model provided to us, and then construction, working and mechanism and performance. After that the cooling and other auxiliary system, then its maintenance and troubleshooting, and at last its industrial application and conclusion. Now, first, what is a diesel engine? Basically, diesel engine is a internal combustion engine where the ignition of fuel is uh, by the elevated temperature of air to mechanical compression. Basically, in the diesel engine, this is CI engine, compression ignition engine, where the hot air is compressed and which is then used to ignite the fuel. Here is the classification of a diesel engine. Basically, this classification is based on the power and size of engine. There are three types of engines: small, medium, and large. For a small engine, the engine having power less than 188 kV kilowatt or 252 horsepower. This is small engine. Or for medium engine, the power range is from 188 kilowatt to 750 kilowatt, and same for large, the engine having power greater than 750 kilowatt. These are large engines. Now, here is general classification of an engine. Basically, engines are classified into two categories. Generally, number one is stationary engine, and second is portable. Now, what is stationary engine? Basically, stationary engines are those engines whose framework are fixed and we cannot move these engines from one place to another place. Basically, these engines are used to work for the equipment such as the pumps, generators, mills. Basically, we use engine to run the factory machinery and cables car. And, and other one is a portable engine. Basically, a portable engine is also fixed and it sits on same place, but for its application or for its use we can move or shift these engines from one place to other place using wheels and the skids. Now there are the two types of stationary engine. Number one is spark ignited and set two is compression ignited. Now, basically, spark ignited engines having a spark plug, which is used for the ignition of the air fuel mixture. And second one is compression ignited, where the fuel is ignited using the compression. So, the engine model assigned to us is of Wartsila Industries, Wartsila manufacturers. So basically, Wartsila is based in Finland, and their engines are used for the purpose in marine and energy markets. Nohab. Now, Nohab is also linked with uh, Warsaw, but before the 1970s, it was a separate manufacturer, and after 17, the diesel engine manufacturer was sold to Warsaw, and now it's known as Warsaw Nohab. So, the engine model provided to us has a specification. This 18V25 is a water-cooled engine. Basically, this engine has also water jacket, and it's a four-stroke engine with direct fuel injection. Direct fuel injection means that there is a direct fuel injected in the cylinders. Now, it has also turbocharger and charge air cooler. Cylinder heads with four valve technology. Basically, this engine is provided with the cylinder head having a four valve technology. Basically, it increases efficiency. Since from its name it's 18B, so it has 18 cylinder and V-shaped engine, and its cylinder bore is 25 millimeter. The output obtained from this engine is basically 1050 kilowatt, and it operates at the RPM 720 to 1000 RPM, and it can be operated for both conventional as well as LNG on LNG. So here is the cross section of a V-type engine. Basically, both the cylinders are at maybe at the angle of are they at angle of 90 or 60 in a V-type. So components and spare parts. So if Sham kindly continue.
Assalamu alaikum. Myself, it's Shamali. My group member, Muhammad Rahman, has told you about the classification of engine and the basic intro of the manufacturer company Wartsila and Nohab. Now, I will tell you about its components, or you can say about spare parts. Next. Now, these are the basic main components of the Wartsila engine. First of all, there is engine block, then cylinder head, then crankshaft, and there are many others. And we will discuss them in next slide. And these are other few components. Next. Now, engine block. Engine block is the main block of the engine. It holds other parts of the engine to, like cylinder head is mounted on its top side, and there are also other input intake manifolds and other exhaust manifolds, and there is also below its crank case for oil. And now we come and now the engine block is made up of very solid material, so that it can sustain high temperatures. Now we come to cylinder head. Cylinder head is the part of the engine in which the cylinder block is present. Cylinder block is inserted in its inside, and it closes in the top of the cylinder, forming the combustion chamber, because its inside combustion occurs. Now we come to crankshaft. It's the mechanical part that transforms the reciprocating motion of the piston into rotational motion. And, and it is made up of a very forged steel material, so that it can sustain high amount of torsions. Next. Now come to connecting rod. The connecting rod is a rod that connects the piston with the crankshaft, and it is also made up of forged steel, so that it can sustain high amount of torsion and other irregular forces. Now these are the valves. Valves are used for exhaust and intakes, and engine has basically two types of valves, that are intake valve for injection of air, and the exhaust valve is for exhaust of exhaust gases out of the cylinder or engine. Next. Piston rings are very important because they protect the piston from direct damage. They are attached on the outside of the piston, on the dedicated hole, or you can say about the ring formed on the outside of the piston. Now come to cylinder lining. Cylinder linings are basically the lines on the walls of the cylinder, so that oil can flow up and down, and so that friction can be reduced to a much considerable amount. And fuel injector. As we have studied that Wartsila producing engines are basically of high power. So the most of the high power engines are made work on diesel cycle. So fuel injector is very important, because for diesel cycle fuel injector is very necessary. A fuel injector just work by pressurizing the fuel and then send it inside the cylinder. And next. Now come to intake and exhaust manifold. And intake manifold is basically basically it combines all the intakes. It originate from tank, and then it spreads its intake fuel into many parts, so that each intake pipe goes into each of the cylinders. And similarly, the exhaust manifold basically collects all the exhaust gases from different cylinders, and then exhausts it outside to the main pipe. Now comes to turbocharger. Turbocharger is basically fitted on the exhaust manifold, and it basically pressurizes the inputting incoming air, so that so that the engine can perform very well and increase its efficiency. Turbocharger will be discussed later on in the incoming slides. Next. Now come to camshaft. Camshaft is basically connected to the crankshaft, and it basically operates on and off the valves, intake and exhaust valves. So basically, in electric vehicles, it is connected to the motor, and now it is just connected to the crankshaft, and so it operates with and it's set to the timings by the timing belts. And now comes to main bearing. Main bearing is a bearing which hold the crankshaft in the place, and so that so that the crankshaft can rotate without any fluctuation or imbalance. Next. Now these are few engine auxiliaries. The parts engine auxiliaries are the parts which are necessary for increasing the performance of the engine, and they are attached with the engine, like that purifiers, water jacket, and cooler. Next. Now come to purifier. Purifier is basically attached in the path of fuel, so that the fuel that goes into the cylinder must be very clean. There are basically in the purifier. First, there is centrifugal purifier that purifies the uh, fuel on the basis of centrifugal force, and then there is specific gravity difference purifier that separates others. And there is and in modern technologies, many others are magnetic purifiers and other included. There is mostly 3 to 4 purifiers are attached on the path from tank to into the cylinder. Next. There is water jacket coolers. These are very necessary to keep cool the temperature of the to keep down the temperature of the engine. So it is done by exchanging heat from engine to the cooling water. So cooling basically the cool water is circulated outside the engine jacket, and so the cool water absorbs the heat from engine, and then it is that is uh, radiated into the other large cool water reservoir. Next. Now come to charge air cooler. Basically, charge air for cooler purpose is to reduce the air inlet temperature. And when there is air, when the temperature of inlet air is reduced, then the density of the air also become reduced, and so efficiency of the engine increases. And the air is cooled by passing it into the pipes, and that pipes are passed through cool water, and cool water is cooling the pipe from outside, and by conduction air is cooled, and so the heat of the air is transferred. Now mechanism will be the mechanism. Now our engine is 18V25, and it works on diesel cycle. So diesel cycle has basically 4 strokes: intake stroke, compression stroke, power stroke, and exhaust stroke. This is basically the working of the engine. So in intake stroke, most of the time it the piston goes down, and then the air is injected inside, and then is the back previous slide, and then there is compression stroke. The piston moves upward, and the air is compressed, and then the fuel from fuel injector is spread onto the compressed air. Then there is power stroke. Power stroke is after the combustion, because at the end of compression stroke there is a combustion, and when there is combustion, there is increase of pressure in the cylinder, and that pressure forces the piston to the downward, and so power stroke occur. And when piston moves downward, the flywheel is rotated, and then transfer to the wheels. And then at the end of power stroke, and the exhaust stroke start, and the first exhaust blow down, the sudden decrease in temperature due to the intense exhaust, and then there is simple exhaust stroke. Next, this is just an animation of the working of the engine. The valves are operating and the piston is moving up and down. Next. Next will be explained by the Mohammad Rahman. So keep continue.
Now, let's come to cooling cycle. Now, first of all, we will see why cooling is necessary in the diesel engine. So basically, the diesel engine is working on compression. This is compression ignition engine. So the compression process inside the engine produces so much heat. So we need to reduce that heat because the heat generated is so much high, which is the uh, higher than the melting temperature of that metal from which that the parts are manufactured. So in the cooling cycle, first of all, cold water moves from the carburetor to the engine block, and then which is hot, and it extracts heat from the engine block, and then it moves upward from the engine head, uh, cylinder head, and then move to the carburetor in the form of heat water, and in the back side of the carburetor there is a fan which is used to cool down the hot water. So in this cycle, the water flows inside the engine and extracts the heat. So next, why we need cooling? So basically, cooling is done to remove the excess heat for the engine and then maintains the engine operating temperature. Third one is to remove the waste heat from the IC engine and lubricant and to maintain the temperature range between below the freezing temperature to the 50 degree, and the overheating of the lubricants uh, to which may result in the seizure of piston. For the cooling of the engine, we can use the different coolants such as the water, glycol, mixture, air, silicone oil, extra oil, mineral, and we can may also use water. No, water cooling system. The water cooling system is basically divided into two parts, which are the high temperature and a low temperature circuit. Basically, there are two circuits present inside it, which perform their own works to cool down the different parts of the engine. So first, let's see the temperature water. Basically, high temperature water cools the cylinder liners, cylinder head, and the first stage of the charged air cooler. While on the other hand, the low temperature water cools the second stage of the charged air cooler and the lubricating oil. Now, lubricating oil cooler. Basically, we can use also or lubricating oil for the cooling to reduce the friction between the moving mechanical part and also extract some heat from the component. And as a result, oil becomes hot and thus it is removed from the lube oil by the cooler. This heat is removed by the lube oil by the cooler to prevent both the breakdown of oil and damage to the mechanical part. Second one is a charge air cooler. Basically, charge air cooler is located between the turbocharger and the engine scavenge air inlet manifold. Basically, why we use the charge air cooler? The charge of the air cooler purpose is to reduce the air inlet temperature. So when the air inlet temperature is reduced, the density of the air which is entering inside will increase and engine efficiency will also increase. Now turbocharger. So turbocharger is the main component of the engine which will be used to increase its efficiency. Basically, what turbocharger do? Turbocharger basically increase the pressure of the air which is entering inside the engine. Basically, the turbocharger is placed at the outlet manifold of the engine. The exit the engine and through the turbocharger, and it uh, re-enters through the turbocharger turbine where it is compressed and then reused. Now the main components of the turbocharger here, the turbine and the compressor. So here you can see the compressor is placed, the center housing and rotating assembly. This is center housing and rotating assembly, intercoolant, piping and manifolds, hose side piping and cold side piping. Now what is the function of a turbocharger? Basically, the exhaust inlet from the engine enter through the turbocharger and it moves from the circular path and then exit. Now the exit air again inlet enter into the turbocharger and passing through the compressor where it is compressed and its density is increased and then re-entered into the engine. Working of a turbocharger. Here an animation is shown which shows the working of the turbocharger. Basically, here a four-stroke engine is working where the during the compression process, the hot air is produced and which is then exiting the turbocharger, and the same hot air when go to the atmosphere and enter from the other side of the turbocharger and reused in the engine. This is the filter which is used to filter the air coming inside the engine. So basically, this is a working the turbine. The turbine used in the turbocharger basically it rotates at a 1050 RPM. Due to this rotation, a vacuum is created inside the impeller, and the air rushes to the impeller casing, and its temperature increases. Then the hot air enters the combustion chamber after the passing through the intercooler. So this animation shows the working of the turbocharger. Now, engine performance. Engine performance is basically used to measure how efficient an engine is, or what is the output we are obtaining, and what are the values of the parameters. So, engine performance can be measured using the different parameters. For example, the compression ratio, the swept volume, which is the distance between the top dead center to bottom dead center, then the power output, how much output is engine is providing, then thermal efficiency, to its brake mean effective power, specific fuel consumption means how fuel is consumption, how fuel consumption by the engine. Now compression ratio. Basically, diesel engines are constructed between the compression ratios 14.1 to 20 ratio 1, and our engine 18 with 25 also lies in this range. Swept volume, since this is the diameter of the bolt 250 millimeter and the stroke length is 320, so we can easily calculate the swept volume, which is 15, 70, 79, 63 millimeter cube. Power rating. Basically, power rating is the output power from the engine. So power we get from this engine is 6,000 kVA. The thermal efficiency of this engine lies between the 42 to 50%. Engine performance will be good when. Basically, how we can know that the engine performance will be improved or it is good. Engine performance can be improved by the three ways. First of all, if we improve the fuel economy. Second is if we reduce the nitrogen, the monoxide, and the other hydrocarbon, and if we increase the torque of the rotating at which the rotation and the output.
Now, welcome back. My group member have tell you about the cooling systems. It's few types like water cooling systems and other oil cooling and charge air system. And then it has told you about turbocharger and its working and then other few parameters for indicates engine performance. Now if the engine has some problem, or you have to first of all reduce that problem comes, so we have to do some maintenance, or you can say some protective measures. Next. Now, first of all, we will define maintenance. It is basically the process of keeping engine or equipment in a good condition by making repairs or correcting problems. So there are few strategies. Like the first one is preventive maintenance. Preventing maintenance is for a proactive approach. Like before incoming of any problem, you have to first reduce its chances of occurring, its chances of probability. And then is the reactive approach, which is corrective maintenance. And you have, if the problem comes, you have to do some measures to repair it. And then there is major overhauling, which will be done after a year, or after a very long period. And then is troubleshooting of problems that are very minor or very um, common. Next. Now, this is the first of the preventive maintenance chart that will tell you about what preventive maintenance will you require when you will drive less than 5,000 miles, and you have to require first of all the changing of oil, and then the checking of tires, and then wheel alignments when your car has driven less than 5,000 miles. And when your car has driven 5,000 miles, then you have to first of all check brake inspections, oil change, and gear oil inspection. Similarly for 15,000 miles and 30,000 miles. And after 60,000 miles you have to change spark plugs, because after burning of lot of fuels and other things, basically our engine is Wartsila, so there is no need of spark plug changing. And we have to see the fuel injectors. And similarly after 6,000 miles you have to change engine coolants. This is roughly the estimation on the base of average data collected. You have to keep observing the all the components. If any components uh, be will uh, will be getting a problem, you have to repair them. Next. Now these are few points of preventive maintenance. First of all, I have told you about that preventing maintenance is proactive approach. That before coming of any problem, you have to first reduce its probability of coming, its chances of coming. So first we have to number one is seats and seat belt security. This is basically for the security, for the protection of a person who is driving, or the person who is sitting in the car, so that if any accident occur, he must be safe. Then there is oil level. You have to monitor oil level before driving. You have to first see the oil level, that it is up to the recommended level, because if the oil level is below the recommended level, it cannot, the engine cannot work correctly. Then come to coolant level. Coolant level is very necessary, because you have to cool the engine. And then is first aid kit. uh, Normally the people don't keep that first aid kit in the car, but it is necessary. If there is an emergency, you have to use it. Then comes to fire extinguisher. Then fire extinguisher it will be helpful when your car might catch fire. And then is spare wheel. Most of the car driver keep spare wheels, spare tire. And then is wheel branch and other things too. And now you have to also see that brake fluid level is very necessary, because mostly now there is hydraulic brakes are used in common, so the fluid level must be monitored, and must be refilled if the level is below. And then come to power steering. Power steering, basically the mostly hydraulic steerings are used, and so you have to also see the steering fluid also. And then is the few other points like the body panel, windshield and windows, side mirrors, logbooks. And then comes to battery. Basically the battery, you have to see that battery terminals are correctively connected, and there is no loose connection in between them. And the level of water or acid in the battery, and the pH of acid in the battery must be carefully monitored, must be regularly checked by technician after a month or two. Then is the tire condition. on a long or you can also say that on a short drive you have to see the tire pressure and conditions, because if there is no other technician nearby, you will be facing problem. Then is wheel nut tightness. This is the most important. You have to first check that all nuts are tight before when you drive a car, before when you drive engine or other the uh, because that engine is also used in some large, uh, you can say in large trucks or large other things. So you have to also see all the things also. In view of the respect of the engine, you have to nut tightness is basically related to the flywheel nut tightness and other things, and the other battery connections are also related to the other, if other motors are used for pumping the fluid into the engine and other things. Next, then comes to corrective maintenance. Corrective maintenance is the basically maintenance of when you are facing some problem, and you have to repair it, or you have to you have to do some you have to do some maintenance for it. So there is basically the few points like fail repair. If there is something failure, you have to do some its repair. Then is overhauling, then servicing and rebuild. Rebuild is basically done after that all components are almost wasted. Then you have to rebuild that. Next, now steps for corrective maintenance. These are the few steps for corrective maintenance. First of all, you have to remove or disassemble the engine. Let's an example. Let's see the engine, our 18V25. So first of all, if it is facing problem in the let's you can say in the fuel injector, then first of all you have to disassemble that part of the engine, and then inspect it, that what problem it is facing. And if the engine, if that problem is can be repairable, then you can repair it. And then if the third point is disposing no repairable material, which means that if that fuel injector is unable to be repaired, then you have to you have to dispose it and insert new fuel injector in that. And similarly, repairing worn out parts, the parts that that's the components that are out of order or out that have too much problem that they cannot be repaired, then you have to insert new components that at that place. And then you have to check replaceable part that you have replaced in the supervision of a technician. Next, now major overhauling. Major overhauling is basically the disassembly of the whole engine, and then assemble it after doing necessary repairs and maintenance. So first of all, it has few steps. So first of all, you have to disassemble all the engine. The most major overhauling include mostly uh, above than 50% part of the engine. And then you have to inspect that engine parts and spare parts. And you have to then the prepare and submission of inspection report, that you have inspect all the parts, and you have identified what the problem engine is facing. And then you have to then at the fourth point you have, and the fourth step, you have to overhaul or you have to repair these parts. And then you have to assemble back the engine. And then you start the engine in the supervision of a trained technician that knows that all the components are all the components are assembled correctively, and the repairing is done at good level. Next, now these are the brief definition, or you can description of the steps. Then you can at the number one step, you have you can see that removal and assembly of the engine, and then is inspection of diesel engine and spare parts, and then is preparation and submission of report. Report is because you are a worker. If you are working in industry, then you have to submit report to the officers that they will see what the problem engine is facing, and then they can send that report to the manufacturer, and they will recommend the proper procedure, and then according to that procedure you can repair that engine. Next. Now is fourth step. Fourth step is the calibration overhauling of the engine spare parts. Now you have done with inserting new parts, or you have done with other maintenance. Then you have to calibrate and the engine parts, that your engine is working correctly. First, let's suppose you are inserting a new uh, uh, fuel injector. So first of all you are checking its that what pressure of fluid or fuel he is injecting. Is it injecting the right pressure of the fuel? That is the calibration, and the calibration must be done with the latest tools and equipment. And then is the assembly of the engine. You have to assemble the engine according to the guidelines provided in its book. Then start of engine in the presence of a technician. Next. Then it comes troubleshooting. Troubleshooting basically the finding the case. You have to find the case first of all, and then is doing the maintenance. And let's first these few steps are written here. First of all you have to identify the problem, then gather the information about the problem, that what type of problem you are facing, and then you have to develop solution about that right solution for that which is very feasible and which is very economical according to the industry, and which is also related to that engine. And the fourth point is to implement that solution. And then comes that repeat if the problem is not solved, and if the problem is solved, you get ready for its start. Next. Now there are a few other troubleshooting diesel engine. First of all, these are few A to G are the few problems if the engine is facing. First of all, the point A. Point A is engine not starting. If the engine is not starting, then you have to do troubleshooting. That first of all, you have to identify the problem. Then you have to gather information about that. Then you have to implement finding the correct solution. Then you have to do implement that solution. And then you have to at the last you have checked that your problem is solved or not. These are few problems like high fuel consumption occurs in the engine. Then comes to our engine is overheating. Then the engine is generating low power. Why it is generating low power? What is the problem comes behind that? Then is excessive oil consumption or oil leakage in outside this engine. And then is changing the oil pressure. And then at the last point you are hearing different type of noise from engine. Next. These are the few points that we have already seen, that what is the trouble and what have to do. First of all, we will check first point, that what you have to do if your engine fails to start. You have to first see these causes. There are these causes are written on the checkbook or the related notebook of the engine. That if there is lack of fuel, then engine fails to start. Then if there is defect in our case, there is defect in you can say in fuel injector, then engine fails to start. Then if the battery is weak, you can say that engine fails to start. Then there is then if there is internal problem, if the piston is jammed, or if the piston rings are broken, then also engine fails to start. Or if there is any problem in the intake manifold, that air required amount of air is not going inside the engine, then engine also fails to start. Its recommend is few solutions are written on the right side of your screen. And then is the next problem is engine fails to idle properly. And then is other problems are written. And on the third point, there is low power and engine running even. If the engine is giving low power, then first you can see that why he is giving Why it is giving low power? It is due to the incorrect wall clearance. If the clearance in the walls are not good, then the walls may be getting uh, destroyed, or if they or the exhaust and intake occurs not properly. Then there is if the second point is that improper grade of oil, the fuel is not up to the standard and it is not providing the latent fuel of combustion, and so you are not getting the power. Then is defective in ignition wire. Ignition wire is basically in spark plugs, so it is basically related to SI engines. And its few remedies are that first you have to adjust valve clearance if there is incorrect valve clearance, and then if there is improper grade of oil, you have to fill tank with recommended grade or recommended manufacturer. And if there is a defective in ignition wire in case of SI engines, then you have to replace that defective wires. And on the basic of smokes, on the fourth point, there is on the basic of smoke, you can identify that if your engine is not working properly. Next. Then comes to industrial applications. Industrial application. The engine is transit power sector of Kohinoor Textile Mills, Faisalabad. Because our group member have visited that area and that industry, and he has seen that in the engine that it is working with full capacity, and it is basically a good engine that is delivering maximum power, um, and more power than its comparable engines. Next. Then comes to application. Few other applications are that it is used in marine propulsion, like in case of large ships, and in other textile industries. It is also in use in Pakistan. There are two to three textile industries which are using these types of engine. As Wartsila is basically based in Finland, but its office and its industry is also in Lahore. So that in that the Wartsila engines are also common in Pakistan too. So we can also see that Wartsila is in international manufacturer. So it is also there's manufacturing unit in Wartsila 18 by 25 is also in use in Nigeria at its shipyard. And at the last, I am telling you that it is ideal for small LNG carriers, the tankers, ferries, and tugs. Next. Next comes to conclusion of the presentation that covers various theoretical aspects and technical